Most people look at an AI chatbot and only think about the model. But in an enterprise, the model is only one small part of the solution. Behind that chatbot, there are business processes, data sources, applications, integrations, security controls, and technology platforms. That is where TOGAF's architecture domains are useful. In this video, we're going to break down the four main TOGAF architecture domains: business, data, application, and technology architecture. These are often shortened to BDAT, and by the end, you'll understand what each domain means, how they connect, and how they help us think about AI solutions in a real organization. Enterprise architecture can feel huge, so TOGAF breaks it into smaller views called architecture domains. The four main domains are business architecture, data architecture, application architecture, and technology architecture. The important point is that these domains give us a structured way to describe the enterprise. Each domain looks at a different part of the organization, but together they help us understand how the whole system works. So instead of looking at an AI solution and only asking, what can the AI model do? BDAT helps us ask better architecture questions. What business process does it support? What data does it need? Which application does it connect to? And what technology is required to run it safely? Let's start with business architecture. Business architecture describes the business side of the enterprise. It looks at strategy, governance, organization structure, business capabilities, and key business processes. This domain answers, what is the organization trying to achieve, and how does work actually get done? From a business architecture view, we wouldn't start with the chatbot, but we would start with the business outcome. Is the goal to improve customer service, reduce manual work, or speed up customer response times? Business architecture also helps us understand the customer service process, the teams involved, the business rules, the approvals, and the customer experience. This is where people often get AI wrong. They jump straight to the tool, but they have not clearly defined the business process or the outcome that the AI is meant to support. So once we understand the business process, the next question is, what information does that process need? That takes us into data architecture. Data architecture describes the organization's data assets and data management resources. This is where we look at the information the AI solution needs to work properly. So for the AI customer service assistant, that might include customer records, case history, product information, or knowledge articles. But data architecture is not just about listing data sources. It also helps us think about the quality, ownership, privacy, access rights, and security. So which system is the source of truth? Who owns the data? Is the data accurate and up to date? Or should sensitive fields be masked? This matters because an AI solution is only as useful as the data behind it. If the data is incomplete, outdated, or poorly governed, then the AI may give out the wrong answer or expose the wrong information. So data architecture makes sure that the solution is powered by trusted, well-managed information. And once we know what data is needed, we then need to understand where the data lives and which systems will use it. That brings us to application architecture. Application architecture describes the applications used in the enterprise, how they interact, and how they support business processes. This is where we'll map the systems involved. And in our customer service example, the application landscape might include the CRM, case management system, knowledge base, and integration services. The AI assistant is only one part of the bigger application landscape. So for example, when a customer asks, what is happening with my support request? The AI assistant may need to check the customer record, retrieve the case status, search the knowledge base, and decide whether the request can be answered or needs to be escalated. And that may involve several systems working together. Application architecture helps us understand those systems, their responsibilities, and how they need to interact. This is important because an enterprise AI solution rarely works in isolation. It usually needs to connect into an existing application and business workflows. But applications still need a technical foundation to run on. And that brings us to the technology architecture. Technology architecture describes the technology foundation that supports the business, data, and application services. So, in TOGAF terms, this includes the logical software and hardware infrastructure needed to support the solution. For an AI customer service agent, that could include cloud platforms, APIs, identity and access management, and many other services. This is where the domain that helps answer questions like where is the solution hosted, how are the integrations secured, how is access controlled, and how is performance monitored. And this is where we move from a demo to a real enterprise solution. A demo might work with one chatbot, one knowledge article, and one test user. But a production AI solution needs secure access, reliable infrastructure, monitoring environments, and support processes that are resilient. Technology architecture helps make sure that the organization can actually run, support, and scale the solution safely. So, how are these domains connected? The business process needs information, and that information is created, stored, and managed as data. That data is used by applications, and those applications run on technology platforms. So when we design an AI solution, we should not only ask what the AI model can do, we should ask what business capability does it support, what data does it need, what applications does it connect to, and what technology is required to run it securely and reliably. And that brings us to our next point, architecture artifacts. A business architect might use capability maps, value stream maps, process models, or organization maps. A data architect might use data models, data flow diagrams, or matrices that show how data relates to the business function and applications. An application architect might use an application portfolio, communication diagrams, or integration views. A technology architect might use technology portfolios, platform diagrams, cloud diagrams, or environment views. These artifacts help teams see the architecture clearly. They support better decisions, make risk easier to identify, and help explain how the different parts of the enterprise fit together. In an AI project, these artifacts can show what business capability the solution supports, what data it accesses, which system it connects to, and how it is hosted, secured, and monitored. So BDAT is not just theory, it gives us a practical way to organize the architecture around an AI solution. So to recap, TOGAF uses four main architecture domains: business, data, applications, and technology. Business architecture explains what the organization is trying to achieve and how work gets done. Data architecture explains what information is needed and how that information is managed. Application architecture explains what systems support the business process. Technology architecture explains the platforms and infrastructure required to run those systems. Together, these domains give us a holistic view of the enterprise, and when we apply this to AI, they help us design solutions that are connected to real business outcomes, powered by trusted data, integrated with the right applications, and supported by secure and scalable technology. In the next video, we'll look at architecture states. That means current architecture, target state, and transition architecture. These states help us understand where the organization is today, where it wants to go, and how to move there safely. If you're also studying TOGAF Foundation, follow along with the playlist and I'll keep working through each concept step by step using practical AI examples. I'll see you in the next one.